Now, the two most important things, principles. Now, the two most important principles in software development. Do the following steps. 1, make it work. 2, make it fast. And 3, make it elegant. But first, before you try to make it elegant and you come up with the most beautiful design, what's the first step? Make it work. An ugly piece of code that you can demonstrate is better than a beautiful piece of code that you never finish. So make it work. Now, the second one is wars are not won by the smartest, they're won by the less stupid. Let me repeat that. Wars are not won by the smartest, they're won by the less stupid. So, less code is generally better. That's why we want to build functions so that we can reuse pieces, so that we don't repeat ourselves. The more code you have, the more defects you're going to have to fix. And if you program in a language that makes you write a whole bunch of code, even if it's boilerplate and it's copy after copy of basically the same thing, more code will have more defects in it. And one of those potholes in object-oriented programming is that it tends to create a lot of boilerplate. So your code is bigger in more files, that means more defects. So if you can use it wisely and make it so that you don't explode your amount of code, it can be effective. And if you end up with mounds and mounds of code, it can be a nuisance. So instead of building mounds and mounds of code, if you have more pure functions, that's better because they don't have side effects, they're easier to test, it's easier to see what goes in, what comes out. That's a better approach. But not all things can be built in pure functions. Some things naturally have side effects. Like you're storing data for later, you're running it over and over again. You've got to keep information around. And objects are really good at that keep information around part. So maintaining state is one of those things that objects are really good at. So if you've got to maintain state, objects are nice because they give you an interface to that state that allows you to limit how it's changed and track how it's being manipulated. And that state information, that piece of information that you're trying to keep from run to run can be really important. Now, state information for the sake of state information is just always bad. And if you can not have state information and instead of having a state, you can have something that's a pure function, it's just easier to test. And since 95% of our time is spent testing and fixing, that's a good thing. Most of the time, things that improve testing are winners. So if you can build something that's easy to test and it does the job versus something that's hard to test and it does the same job, the easy to test thing is going to be the winner. Now, lots of people go through and they build, here is the fancy design for all these pieces. They hook together in this fashion, they do this group talks to this. Design is important. You should start out with a design. It gets you an idea of what you're trying to build. Especially if you're trying to peel this apart into different people working on stuff, it gets you a starting point. But let's be serious about design. Designs are as good as the amount of time you spend testing them. Let me say that again. Designs are as good as the amount of time you spend testing them. And usually designs are not tested at all. They're just designed and then handed to the developers, and the developers go off and build something, and then when they get done building it, they find out that, no, this isn't what we really needed, because they didn't test the design itself. The way to overcome this kind of a problem is don't build this monolithic design for everything. Build a little piece of it and then take it back to the customer and say, is this really going to solve what you need? And then go back and build another little piece and go back and forth and communicate. And suddenly now you're testing the design. You're finding out that, oh, what they really needed was one of those in there. Okay? So, test your designs. Build your code and frequently get to the point where you're actually testing it and seeing what it does. And that process of frequent testing and correction will mean that you can build big things that actually work and meet people's demands. But there's another way of saying that, designs are only good as the tests that are applied to it. And I like that one. And that is that no battle plan survives first contact with the enemy. And, it's a good way to think about it. And these people are not necessarily your enemy, but whatever your plan is, you actually have to go out and build it, say, is this what you want? Let's find out. I talked a little bit about how objects came about, which is, Java got marketed, it solved a bunch of problems, it was really good. The real problem that Java solved, it didn't solve it well, but it did solve it, was memory management. And we have built better memory management systems today in languages like Python than Java, but this automated memory management was a really useful thing. And, Java went and it's been going down for a while. This is like 1992. For a while, Java ruled the world. But that time has come and gone, and there are other programming languages. And consequently, as we have gotten down through the years, we have found that object-oriented is not the solution to every problem in the world. It is a useful tool amidst many different approaches, and there are other things, that some of which have been incorporated into Java now, that are more useful, like interfaces. But, Java is mostly object-oriented. And lots of languages ended up having object-oriented either bolted on the side or added intentionally. I think the implementation of object-oriented in Python is very good, but it is an add-on. And that's what we're going to cover next, is how you manage state, what the good and bad things are about object-oriented, and how you use objects effectively. Now, basically, the idea behind objects is we have some chunk of data, and that data is going to have some set of functions associated with it. And those functions tend to be the interface to the data. Now, that's not the only way we can interface to data, but most people that are object-oriented purists, they have taken on the religious mantle of object orientation, will just come out of their complete skin if you say, no, this piece of data over here is public and you can directly access it. They just come unglued. So I'm going to forewarn you that this happens, and there are plenty of them out there. But, the original design for object-oriented was that an object was a component that received messages and sent back messages. And that didn't mean that the messages had to be function calls, they were messages. And that made a lot more sense, and one of those means of sending messages back and forth was communicating by providing interfaces directly to data. So, we're going to look at that, how you expose pieces of data, even though lots of people will get bent out of shape about it. Sometimes it's a useful thing to do, and you should know how to do useful things, not just the ones that make everyone happy. But by and large, we're going to have some sort of a function, and the functions are going to allow you to expose the manipulation of state information in whatever this data is. And that manipulation of state it's hard to encapsulate, and it's important, so we're going to look at it in that kind of a fashion. Now, there are other things that you can do with objects. You can build them into big hierarchies. We're going to talk about some good and bad of hierarchies of objects. Let's not beat around the bush. Most of what we talk about in hierarchies of objects, I'm going to tell you, is leave something to be desired. Let's put it that way. But it is available, and you're going to see a lot of that. And you need to know how to read that kind of code and look at it and go, okay, this is what they're trying to do here, and this is why they did this. And go, okay, it's harder to digest and read, but I can understand it and I can work with it. So that's the direction we're headed in. Now, we have a midterm test coming up. It is going to be a take-home. I'm going to have some other things that I'm going to cover for the midterm test in terms of patterns. The biggest one of those is you ought to know how to do a loop. I promised I would walk through a while loop. If we have a list, something like this, while I is less than the length of the list. That's a capital L there, that's this guy right here. You do something inside, and at the bottom you do I equals I plus 1. Okay, that will be on the midterm. I'll send that out in an email as well, so you don't have to read this version of it. But we have covered that. That is an important pattern. And you also in the land of patterns, you need to know how to do an if with an else and what that means, and be able to read a piece of code that says this and tell me what the output would be from that. So those are the kind of things that are going to be on the midterm, as well as some of these other things in a little bit more abstract sense. I don't think the midterm is going to be hard. I think it's going to be pretty easy. I will be giving you a more detailed, this is what's on it in a written form, so you can look through these things and ask questions before we get to the midterm. So that's kind of the plan and the picture, and let's go have some fun. And we'll have some fun with objects. How's that?